Hello, this is Mr. Stansbury. I'm going to take you through the 11G notes on capacity. So at the end of this, you should be able to say I can convert volumes within the metric system, and also I can use volume formulas in various real-world type situations to solve problems. Alright, so let's jump straight into first example, which is from example 29, page 385. We're going to convert 4.2 liters to milliliters. Now, they do actually have a little capacity units over here, but so really it's liters to milliliters. 1 liter is 1,000 milliliters, so we basically take this decimal place and move it over 1, 2, 3 spots. So it should be 4,200, because these are both going to turn into zeros, right? 200 milliliters. Alright, oops, that was a bad circling job. There we go. Alright, so second one, 38,600 liters to kiloliters is going to, so we're going from liters to kiloliters, so 1,000 liters is the same as 1 kiloliter. So here's the decimal, and now we're going to move it the other direction. 1, 2, 3, so it's going to be 38.6 kiloliters. Alright? Alright. Also, another way to look at it is you could take the 4.2 liters, changing that into milliliters. Again, since it's getting bigger, we're moving it to the right. The liters, 1,000 liters is going down to kiloliters. It's getting, there's going from 1,000 down to 1, so it's getting smaller. So move it back to the left 3 spots. All right. Okay, second example. Example 30 from page 386 says convert 9.6 liters to cubic centimeters. Okay, so over here on the side here, we've got 1 cubic centimeter is 1 milliliter, and 1,000 cubic centimeters is 1 liter. So there we go. So this 1 liter is going to now get bigger. So we're going to move it over 1, 2, 3 spots, because 1 liter is 1,000 cubic centimeters. So that's, again, these are going to be zeros. So it's 9,600 cubic, golly, having a hard time with that, cubic centimeters. Alright. And then liters to meters cubed. Here's liters, here's meters cubed. So again, we're moving from something big to something smaller, so we got to move the decimal to the left. 1, 2, 3 spots, because there's 3 zeros there. So it's 3.24 meters cubed is the same thing as 3,240 liters. Alright. Okay, next one, example 31 from page 386. How many kiloliters of water would a 3 meter by 2.4 meter by 1.8 meter tank hold when full? So let's see, if we figure out how many cubic meters it holds, that's the same thing as a kiloliter. 1 cubic meter is a kiloliter. So might be handy to make some kind of drawing here. This is obviously not to scale. Just trying to make this work here. Alright, so let's say we have, let's see, this will be our 1.8, because that looks the smallest. Let's do this as 2.4, and this as 3. So so let's see, basically define the volume of that. Volume, just length times width times height, right? So volume in this case can be 3 by 2.4 by 1.8, right? So let's use our graphing calculator, use our calculator to figure that out. So turn that on, clear it off, and we have 3 by 2.4 by 1.8. And we get 12.96 meters cubed, which is the same thing as 12.96 kiloliters. Alright. Okay, one last example, and this is where it gets good. So, example 32, page 386. 17.3 millimeters of rain falls on a flat rectangular roof of length 10 meters by 6.5 meters. So we're having to assume that this is the, oops, sorry, we have to assume that this is the, oh rats, what am I doing here? There we go. That this here is the height. Okay? So you got a flat rectangular roof, 10 meters by 6.5 meters. Alright? And it's all going to drain into this cylindrical tank. Alright? So let's just draw our roof here. Yuck. But you get the idea. So let's see, it's 10 meters by 6.5 meters. And it's all going to drain off. Let's make that our spout here. Into this cylindrical tank. Oops. Let's do this. Alright. And this cylindrical tank has a diameter of 4 meters. Alright. So this roof here, and then also it's by 17.3 millimeters of rain that fall on that. So these are both in meters, and this is in meters, and this is in millimeters. So King Henry died unexpectedly by, oh wait, not by, but drinking chocolate milk, right? So here's our millimeters, centimeters, decimeters, units. So we have to move back 1, 2, 3 to get back to meters. So 17.3, move back 1, 2, 3, and that's 0.0173 meters for the height, right? So the height is pretty small, but that's alright, that'll work. So let's figure out the total volume that's going to fall on the roof. So the volume is going to equal these three multiplied together, so 10 by 6.5 by 0.0173. Alright, so graphing calculator. 10 by 6.5 by 0.0173. Right? And we get that the volume is 1.1245 cubic meters is the amount of volume, right? So the volume on a cylinder equals pi r squared, the area of the base, times the height. Okay, so we know that the total volume that's going to fit in that is this 1.1245, so let's put 1.1245 in for the volume. That's going to equal pi times the radius, which we actually know is going to be half the diameter, right? 4 divided by 2 gives us 2, so the radius is 2 squared times the height. So basically what we need to do is just divide both sides. That's 2 squared. Divide both sides by 4 pi, right? Because those will reduce and these will reduce. So divide both of them by 4 pi to figure out what the height's going to be. So let's see, let's take 1.1245 and divide it by, let's do parentheses, 4 pi. And we get that the height is 0.0895, let's go with 895 meters. So it doesn't, I don't think it's specified. Let's see. Oh yeah, it does, in millimeters. So if that's meters, we got to go over, there's our units. We got over 1, 2, 3 to the right. So we got to go over 1, 2, 3. So the height is going to be 89.5 millimeters deep in of the rainwater. All right. Let's see. yeah, I think that pretty much does it. So you should be able to now say that you can convert volumes within the metric system, and also that you can use volume formulas in various real-world type situations to solve problems. All right, if you have any questions, please ask. Thanks.